Hello sir, my name is Atharva Bende and this is my business and health analytics project made in Power BI, and topic for my project is AQI of different cities. So for my data, I have used 5 different data sets of city day, city hour, station day, station hour and stations. And the data looks like this. It has a city column, it's a date column, it has particulate matter, nitrogen oxide, nitrogen dioxide and multiple different gases, and it has a different column of AQI and AQI bucket. So I have imported this data in Power BI and I have used Power Query to format and change the data, and I have also created a separate city table. I have formatted city day and all the other tables and changed all the number value and the word values. I have also created relationships between the tables, and I have connected the city and station tables to all the other tables. The city table is connected by city day and the city hour, and the stations is connected to station hour and station day, and the stations and city are connected to each other. Okay. So all this, the whole model helps me to relate data with each other when I was making the visuals. So for the report view, I have made 4 different pages. The first page is a city page, which I have made 4 different visuals in this. The first is a stack bar chart. This is the second is a map. Third is a clustered column, and the fourth is a slicer. So in the stack bar chart, there is the x-axis contains the average of AQI. The y-axis contains different cities. For example, we can see Ahmedabad, which has an average AQI of 300.22. Delhi has an average AQI of 258, and so on. There are like multiple cities. Mumbai has an average AQI of 40.64. These all data is between 2015 to 2020, and to change the colors of the whole table, I have used conditional formatting in the bars, which we can see from here. So the green color indicates the safer AQI values, which is close to 0. The moderate values is around 700, and the harmful or lethal AQI values are shown in red as it reaches 200. Similarly, the map also shows different cities, and the bubbles also have conditional formatting, which shows the harmful and safe AQI in that particular city. So for example, if I zoom in Ahmedabad, you can see there is a red bubble as the Ahmedabad has an AQI of 300. And if we see Mumbai, we have a lower average AQI, and it's showing a green color. So in the next table, it is a clustered bar chart, which contains, in which x-axis is different cities and y-axis contains these 6 different values. It shows the average of ammonia, nitrogen oxide, nitrogen dioxide, nitrogen oxides, ozone and benzene, and these all gases affect the average AQI, and this graph shows the percentage of the value of average value of these particles in the air. And this is a regular slicer, which is used to select a particular city so that we can get a detailed information on the city. So for example, if I select Ahmedabad, we can see the graph only shows one reading. You can see the average AQI. The map zoom to Ahmedabad, and now we can clearly see the average of all different components, all different gases, which is in the column chart. So for example, we can see the nitrogen oxide had an average of 40.56 parts per million. Nitrogen dioxide had an average of 39.53, and so on. That shows Amravati. The map changed to Amravati, and it shows the AQI and it shows different components. And deselecting the slicer returns all the stats back to normal, and we can see the whole map has turned back to normal, the graph has turned back to normal, and we can see all the different cities in the first one. For the next page, I used 4 different line charts. The first chart shows the average of AQI in linear form. It is sorted into ascending order. So you can see that Ahmedabad has the highest AQI and Aizawl has the lowest AQI. So using all the, as I used all of them are line charts, the line charts are connected to each other. So I can select in any of the cities, and the whole below line charts changed according to the city selected, and the vice versa also happens. Like if we deselect the city and I select a year, we can see that different cities shows different AQI readings according to that year. And in below are 2 graphs which are sorted by month and day. So in 2017 we can see that the AQI slowly decreases from the winter months, January, February, March, and it reached the lowest point during the August, September seasons. This is the monsoon season, and in that seasons the AQI is lower because of rains and winds, and the AQI suddenly increases during November and December because of winter and because of festivals like Diwali and all. It can have some impact on the average AQI. And the months, we can also select a month from this, and that changes the AQI per day chart in a month. So we can see the AQI rises and falls down and then rises again. That indicates the occurrence of holidays or weekends, during which people may go out and roam multiple places using their own vehicles and cars, and because of that the average AQI increases. So these are all line charts, shows different timelines of the AQI relating to their cities, the time and dates. For the next page, I use the data of stations, multiple stations in different cities. Similar to the city page, I use nearly same visuals as the city page. It is a stacked bar chart, a clustered column chart, a slicer, a table, and a map. So same stuff I've used, same conditional formatting setup I used in here, same formatting I used in here. New thing I used is this table. The table shows that which stations had active or inactive AQI equipment at that time. So these are now sorted ascendingly, and you can see there are multiple stations which do not have any AQI equipment at that time. So for example, let us choose Worli. So we can see the AQI of Worli as a region. It has an average AQI of 95. All the gases, we can see all the segregation of all different gases in the air which affected the AQI. The map is zoomed accurately into Worli area, and we can see that Worli had an active AQI at that time. And we can use the map to select one particular region. So let us zoom into Mumbai, and we have the data of Juhu in Vilepale, and the map and the graph highlights the Vilepale West area, and it shows the average AQI of 81. It shows us that the Vilepale had an active AQI equipment at that time. We can also use this using slicer, like if there are like multiple hundreds and hundreds of different stations here, but we know the stations using the map. We can select on that point, we can see which station it was, and then we can look that station in the slicer. So let me find Vilepale. Okay, so I found Vilepale, and now I can get specialized data for Vilepale here. And for the next page, it is a summary page I have created. I used 3 different visuals here. The first is the key influencers, this is a word cloud, and this is a decomposition tree. So the key influencers helps us analyze the data which we have used, and it gives us how one data relates to another data, like how change of one data leads to change in the other data. So here it has given us the question, what influences AQI to increase? We can sort this by increase or decrease. So we have like multiple answers. So it says, I have analyzed this visual using only the particulate matter. I can use different molecules too, such as I can add let's see, I can add carbon monoxide too, and it runs an analysis, and it can also add all this different data here. So the carbon dioxide does not relate to these data, so it does not work in that manner. But if you have some other sort of data, if you are working like in sales and all, we can use different types of data to analyze this. So to demonstrate, this question says that the average of PM10 is more than 180. So as the PM10 is more than 180, that leads to average of AQI increase by 148. Similarly, average of PM2.5 goes to 72.60, the average increases by 83. And similarly, the PM10 has a range of 129 to 180. It's still the AQI increases, but it is not as extreme as when the PM10 is more than 180. And so it also creates a graph that shows that different ranges have different effect on AQI. Similarly, I can turn this to decrease, and it shows that if the average of PM2.5 goes to 72.60, the AQI, because of that, the AQI decreases. You can see the average of AQI decreases. And if the average of PM10 is 0 to 87, you can see the lowest graph here. As it has the lowest range, that leads to a decrease of AQI. For the next visual, I used a word cloud, and different fonts or different cities indicate that which city has a higher AQI and which city had a lower AQI. So we can say that Ahmedabad had a higher AQI, Delhi and Gurugram had higher AQI, Mumbai as well, and all these cities have lower AQIs. Next visual is a decomposition tree. It is more of a filtering tool than a visualization tool. It also visualizes some important information, but if we use this tool as a filtering tool, this tool also affects all the other visuals in here. So for example, if I have analyzed using average of AQI, and that average of AQI is analyzed by the city, the year, and the month. So if I select, let us see, if I select Bangalore as a city, so we can say that, so it has given me different years, 2015 to 2020. I can select any of the year which I want, and I am selecting 2019. So it has given me data of every month of 2019, like how the average AQI was in 2019, what was the average AQI every month. So if I select February, it became a criteria for our selection, and after I selected February, it has analyzed again, and now it is giving me new analysis of influencing, like, and I can use this new analysis to influence that how my AQI can decrease. So at that time in Bangalore in 2019 February, when the average of PM2.5 was more than 48, the average of AQI the average of AQI increased by 38. And next, if the average of PM10 was more than 108 at that time, the average increased by 33.17. Similarly, I can do for January, and then it reruns the analysis, and we can see the same type of values, but as these had really close readings, it shows us that it still shows us that because the average of the whole year. So that is how the decomposition tree used. It is used less as a filtering tool, but it is used more as a visualization tool. As we can see using this, or these bars and all, I use conditional formatting on all of this, and it shows that how cities had higher AQI and lower AQI, and we can use that to visualize all the data. So this is all for my Power BI project. Thank you, sir.